This is Devasis Raut. So today we'll be learning on static members and their control flow. Okay. So like in this session that we will be learning like static variable, static block, static method, and like how the memory are being assigned to them and how they are being executed when they are being called. Okay, all these things. So first of all, if you tell it as a static, okay, static inside the class level, inside the class we have like for static we have static variable is there, we have static block is there, we have static method is there. Okay, so what members are called static members? So in this, the class level members which have static keyword, these are called static members. Okay, so for types of static member we have like static variables are there. Okay, and we have static methods we have there, static blocks we have there, and main method is there. That one is also a simple method, but we treat it as a like a special method that I included, but it is also a static method only. So methods and main method. Okay, and when do all these members get memory location and by whom? Okay, when do all these members get memory and by whom? Okay, all static members are identified and get memory location at the time of class loading. Okay, by default class loading by default by at the time of class loading at the time of class loading. Okay, class loading by default by JVM in method area. We learned about method area, heap area, Java stack area in our previous session. Please go and watch that one. Okay, so we will be all the static members will be identified and get memory location at the time of class loading. Okay, in the method area. So what is static variable? So like a variable which have like static keyword is there, that one is static variable. Okay, so like one question is there. Sorry. Another question is there. Does JVM execute static variables by default? Yes, it executes static variables. Okay, means provides memory location at the time of class loading. Okay. So how many static variable we can define in a class? Is there, if there is one question is there, then we can define like multiple static variables, but like every name should be different, or else we will have like same name will be there, then the compiler will throw the error saying that we have duplicate variables. Okay. So what is the order of execution of all the static variable? So as I told, in order they are defined from top to bottom, like static and non-static flow I have given in a video. So please watch that. So in the order they are defined from top to bottom, like that the execution of static variable will be like that only. Okay. So I will be explaining these things in terms of example. So what is the order of execution of all static variables in the order they are defined, like top to bottom, from top to bottom. Okay. So like when, where, how, and by whom. Memory location is provided to static variable. Okay. When class is loaded, JVM provides individual single copy of memory location to each static variable in method area only once in a class lifetime. So like okay, so increase this one. Okay. So like when, where, and by whom the memory location will be provided to static variable. So when a class is loaded, the class will be loaded only once, not like the class will be loaded multiple times. Once the JVM is off, the class will be loaded for once time, for only one time, not for multiple times it is loaded. So at the time of class loading, then only the variables will be getting the memory location for them individually. Okay. So we learned about the order of the execution. Does JVM execute static variable by default? When do all this memory get location and by whom? All this question we read. So moving forward, what is the lifetime and scope of static variable? We already learned that in the variables chapter. Still I am repeating the things so that you will understand them more clearly. Like multiple times if you repeat one thing, then the understanding will be much better. Scope of static variable. Static variable get live as soon as class is loaded into JVM and is available till class is removed from JVM or JVM shutdowns. Shutdown. Okay. And its scope is class scope, means it is accessible throughout the class directly by its name. Okay, and outside class by its class name, provided it is not private, because private ones we cannot call from outside of the class. Okay, like default one we can call outside of the class but inside of the package, but public and protected we can call outside of the package. In protected, that is, there is rule is there, like the class must be subclass and the object must be subclass object, then only we can access a protected variable. But for public there is no rule is there, we can access it anywhere, any place, provided it is not private. Okay, like we can say example is there, class example we have a static int a equal to 10 is there, and we have a static void m1 method is there. And if we are going to use this one, so class sample we have, and we have static void m2 is there. We have there, if we are going to access the a variable from the example, we can directly access to the class name because it's a static one. So static will get memory inside the class. So inside the class, if its memory is there, so we can access in the we can access the class, then only we can access the variable. So example dot a, we can access the a variable. Okay. So can we declare local variables or parameters as static? No, it is impossible. Okay, we have already discussed that, but still, can we declare local variables or parameters as static? No, it is not possible. It leads to compile time error, illegal start of expression. Static keyword is not allowed inside a block. Okay, because as being a static variable, it must get memory at the time of class loading, which is not possible to provide memory to local variable. Let's see that in example. For example, we have class example is there. And the class example, we have a static int a equal to 10 is there. Okay, if we will have like public we have public static void main method is there. Okay, array args is there. So here if we are going to write like a static int b equal to 20, then it is wrong. Like here the compile will give error that inside, that is inside a block, a method is also a block. So inside a block the static is there. So inside a block the static is there. Okay, this one inside a block it is there. So we can at the time of class loading it cannot be, this variable cannot be loaded at the time of class loading, because a method will be executed. A method can be like its name can be declared, or all the things can be mentioned in the method area, like main name can be mentioned in the method area of the means of this example class. But this method will be executed at what time? This method will be executed at the time of invoked, because when JVM will be invoking the main method, then this one will be executed. Okay, not at the time of class loading. Okay, so after it being invoked, then only the method will be executed, then only this static variable int b will be executed and its memory will be there. And that is wrong, because static means at the time of class loading. Okay, after class loading, then only a main method is called. After the class is loaded, then only the main method is called by JVM. So this static rule is not satisfied. So here the compiler will give us error. Okay. So we have learned like types of static members, and when do all this member get memory location. Does JVM execute static variables by default? What is the order of execution? When, where, where, how, and by whom memory location is there? What is the lifetime and scope? We learned these things. Okay. So now we'll be learning like what will be the JVM architecture with the static variable. Okay. So can we declare local variables as static? This part we have completed. Okay. And now moving forward, like what is the JVM architecture with the static variables? That one we are going to see. So JVM architecture with static variables. Okay. So like we will write one program, and for that program we will be drawing the JVM architecture. So like there is a class is there, class example, and we have like static int a equal to 10 is there, and we have a static block is there. Okay, so inside that block, inside the block there is one variable is there. So inside a static block, can we define a static variable? No, we cannot, because static variable can only be present in the class level, not inside any block, not inside any method, because that one will be initialized at the time of class loading. So here we can write a variable, but that must be a local variable. Okay, and we have like public static void m1 method is there, and we have public static void main method is there. Here we will be calling the m1 method. Okay. So you are good now with the program. Yeah. So moving forward with the JVM architecture. So like when the class will be loaded, JVM architecture, we are concerned about three parts: the method area, heap area, and the Java stack area. So here it is the method area, and here it is the heap area, and here it is the Java stack area. Okay. Under Java stack area, we have two threads are there. One is main thread and another one is garbage collector thread. So the stack frames for various method execution and block execution, we will have the main thread. Okay. So when so here like a object will be there, that is of class java.lang.class. This one, java.lang.class object will be there. So inside it the class will be loaded, like the example class, it will be loaded here. So like example.class will be there. Okay. So we are good now. So first of all, when the class is loaded, so for the static variable, this part will be like the declaration part will be executed first, then the static block or else any static variable, those declaration part will be executed like top to bottom, like in this order, top to bottom as they are defined in the program. Then the initialization part will be come, and the variable will be also initialized from top to bottom. Okay. So like here a memory will be created for A with default value. Okay. Like 0 will be there. Later on the static one will be called. Like here all the names will be there, like static block will be there and M1 will be there and main will be there, like this. So like int A, this part int A, the declaration part will be executed. After that the static block will be executed. So it will be searching, yeah, the static block is there. So for that a stack frame will be created. Static block, a stack frame will be created, and the SOPLN statement, the variable local variable is there. So that one will be memory will be there, like it will be assigned with 20. Yeah, good. Yeah, 20 will be assigned here. So after the block execution, like the end of the curly braces came, so this frame will be destroyed. Okay. This variable will be destroyed first, then the frame will be destroyed. Okay. After that, we will be getting the A equal to 10 part, like the initialization part will be there, because no more static variable or blocks are there. So A equal to 10 part will be executed. So this 10 will be striked out, and in here the 10 will be replaced. Then the control will come to main method. Okay, inside the main method we are calling the M1 method, this one. So for that a main stack frame will be created. Main stack frame will be created. In it we are calling M1 method. here is a statement is there. So like for m1 a stack frame will be created. Okay, if there is some logic, those logic will be executed here. Okay, those logic will be executed, and after the end of the curly braces of the m1 comes, so this m1 stack frame will be destroyed. Then is there any logic in the main method? No, there is no logic in the main method, and the end of the curly braces also came. So main method stack frame will be also created. So there is no logic or anything left in this class. So like this main thread will be destroyed, and like all the things will be destroyed, and the class which is loaded, that one will be unloaded. Okay, so that is the flow for the static member. So what is duplicate variable? A variable that is created with existed variable name in the same scope. The important part is the same scope. Okay, same scope. Scope means method scope is there, one is there, and we have block level scope we have there, and we have class level scope also there. Okay, so if we will define a duplicate variable, then it leads to compile time error. Like it will tell variable is already defined. Okay, like if we try to change the data type or modifier, okay, or its assigned value, then also we are not allowed to create a duplicate variable, because name is there na. Okay, name is there, that is called duplicate. Okay, same name is there, so we know variable are like named memory location. The name is already existed, so even though you change the modifier, or you change the assigned value, or you change the data type, so it does not affect that. It will still throw the compile time error, even if we change data type or modifier or its assigned value, we cannot create another variable with the same name. Okay, are you clear on this? But the main part I told, the main part is what? Same scope. Scope is the important part. So if you change the scope, then we can give multiple variables with same name. Like in the class level, we can define a variable with name A, and in another method inside that we can define a variable with name A, but those A variables are different. The first one A, which we defined at class level, that is class level variable, so it might be like static or non-static, and the variable which we are defining inside a method, that one we call it as a local variable. Okay, the scope is different, that's why we can define. Okay, but it is possible to create multiple variables with same name in different scope. For example, the variable created in class scope can be created in method scope. Okay, so through one example we will see that. Let's say we have example like class test is there. Okay, we have a variable like static int a equal to 10 is there. Okay, and we have public static void main string array args is there. Here we can define like int a equal to 20, we can define, but these two are different. This a is known as local variable and this is known as class level variable. Okay, this one and this one is different. Okay, so if you will try to access like SOPLN A, so which one it will take? So in this point the compiler searching algorithm will come. So compiler will search this a variable in its from this line to its above line, it will search. So from this up to this means the starting of the method or starting of the block. Okay, from this point to the starting of the block, is there any a is defined? Yes, there is one a is defined. So it will get the value and it will print here. Okay, it will print here like 20, it will print. So here this variable, how we can access this variable, because every time we will write a, it will print 20. So how we can access this 10? So we can access the 10 by stating it as a class label. So you will write like this, class is like test is there, so test.a, then only it will try to search in the class label. So from this point we are telling compiler that go search a in the class test, not in any method. Search a in the class test. So it will go to the class directly and search in the class level, is there any a is there? Yes, there is one a is there. So here it will print like 10, it will print. Okay, another thing is that one question comes like can we create local variable with parameter name? Can we create? No, both the scope are same, both the scope are only method only. That's why if you will create, it will give us the compile time error. Okay, no, because both parameter and local variable are created in the same scope. So local variable is considered as duplicate variable. Let's see in the example, like there is one class is there, class example is there. Okay, so we have a method is there, public static void m1 method is there. Inside it we are defining the int q we are defining. So inside the method, if you are going to define like this int q equal to 55, then here the compile time error will come, like it will tell that q is already been defined, q is already being defined here. Why are we again defining it in the same scope in the m1 only? Okay, here the compile time error will come. Okay, q is already defined. Okay, so up to this I think we are good. So like moving forward, what is shadowing? Okay, what is shadowing and what is local preference? So creating a local variable or parameter with same static or non-static variable name is called shadowing. Okay, like we'll see that in example. It means, first let's clear about the theoretical part. It means local variable is a shadow of class level variable. Okay, in case when you access a variable in the method, you will get local variables value, but not from the class level variable. Now we saw that example in the previous. Okay, that is the thing. So here we saw now. Okay, here only. Here we saw that the A, whenever the A is accessed, it will first search in the same scope, like it is searched in the method 1. If that is not available, then only it will go to the class level, like it will increase the scope. From the method scope, it will increase to the class level scope. Okay, like here the 20 is available for the A variable, so it is always printing 20. So if we want to access A, we are referring to the class name. That is called shadowing. Okay. Okay. So like example we have class test is there. Okay. We have a static int a equal to 10 is there, int b equal to 20 is there, public static void main is there. Here if you are going to access like a variable, so here what will happen, it will first search in the method scope, like this SOPLN is present in the method, so it will search in the method scope. Is there any A available? No. Then it will go to the class level, like it will increase the scope, then it will find this A variable and it will print. Okay, like it will print here 10. But if we will define here like int a equal to 30 if we will define here, so whenever I will write like SOPLN A, it will always printing 30, never it will go to A. This is called shadowing. So here the local variable A is shadowing this static variable. Like that same way, if I'll write here int b equal to 45, so whenever I will be writing like SOPLN b, so it will always be printing like 45, always it will print. So if you want to access this A, so you will write like this, so it will write like test.a, will write like this. And if you want to access the non-static one, then we need to access like this, new test, will create an object, then we can access like B. Okay. So we are good up to this. So like we'll be learning like we'll be learning in the next session like all these things. We'll be learning like what is the static flow of execution. Then we'll be learning like static blocks. Okay. Then we'll be learning like we have main method is there, so that one will be also learning. The main method, lot of questions will be there, all those things will be learning. So I think first of all we should learn about static block, then only the flow of execution will be good. Like okay, till then, thank you for listening, thank you for your patience.